This is section 3.5, nonlinear functions. Our objective today is to identify nonlinear functions. Let's start with new vocabulary. A nonlinear function is any function whose graph is not a straight line. So for example, this is a nonlinear function. A quadratic function is a type of nonlinear function in which the greatest exponent of a variable is 2. So an example for this is y equals x squared plus 3x minus 4. That is a quadratic function because the greatest exponent is 2. A parabola is the graph of a quadratic function. It'll be a U-shaped curve which may open upward or downward. So an example of opening upward is right there, and an example of opening downward is this one right here. So we're going to look and decide if each function is linear or nonlinear. Function 1, it is a straight line, so therefore it is linear. Function 2, that's not straight, it's a curve, so it is nonlinear. Function 3, again, curvy, not straight, means nonlinear. All right, we're going to sketch the function that passes through these points and decide if it's linear or nonlinear. So if I have 2, 4, x is 2, y is 4, so I go 2, 1, 2, 3, 4, right there. 4 eighths, right about there. 6 12, and then 8 16 doesn't even fit on my graph. But if I connected these, does that appear to be a straight line? It sure does, so it is linear. All right, let's use our table and what we know to decide if it is proportional and or linear. So for proportional, we're going to do inputs over outputs. 1 over 3, 2 over 5, 3 over 7, and 4 over 9. Are these equal? No, they are not. So it is not proportional. But does that mean it's not linear? Let's find out. We've figured out if things are linear. We've got plus 1, plus 1, plus 1. Over here I've got plus 2, plus 2, plus 2. So output over input ratios, 2 over 1, 2 over 1, and 2 over 1. Those are all equal, so that means it is linear. So it can be non-proportional and linear at the same time. So to identify nonlinear functions, in an equation, if the variable has an exponent other than 1, or if it has a variable in the exponent. So some examples of these. Y equals 3x cubed. That is nonlinear. Or y equals 4 to the x power. That's also nonlinear. In a table, if the ratios between the changes in variables are not the same, it is nonlinear. So let's determine if they are linear or nonlinear. Y equals 4x cubed minus 7. Well, this cubed is an exponent other than 1, so it is nonlinear. For B, 8x minus 4. There's no exponent other than 1. If there's no exponent, it's 1. So that is linear. For our tables, we look at our changes. This is plus 2, plus 2, plus 2, minus 3, minus 3, minus 3. So my ratios of changes, we have negative 3 over 2, negative 3 over 2, and negative 3 over 2. Those are all equal, so that one is linear. For D, we go up 1, 1, 1. We go up 7. We go up 19. And we go up 37. Is 7 over 1 equal to 19 over 1? Or 37 over 1? No, it is not. So it is nonlinear. All right, look at these two and tell me which of the two functions is nonlinear. One of them is nonlinear, one of them is linear. So looking at these, the top one seems pretty much simplified. The bottom one will have to simplify. So we'd have 4 plus 2x plus 14 because we need to distribute here. So y equals that. We'll combine our like terms. We get y equals 2x plus 18. Well, that doesn't have an exponent other than 1. This top one has an exponent or a variable in the exponent. So that is the non-linear one. In the bottom, we look at our ratios of changes. So we have 3, 3, 3, 2, 2, 3. So we have 2 over 3, 2 over 3, and 3 over 3. All right, well, that tells me that this one's going to be nonlinear. But let's check just to be sure. Over here, I have a 1, a 1, a 1, a 3, a 3, a 3. So all of those ratios are 3 over 1, and they are all equal. Therefore, that one is linear. Let's look at this example. Decide if the function is linear or nonlinear. A single cell divides to form 2 cells after 1 minute. All cells formed after this also divide in 2 every minute. A function relates time to total number of cells. Let's make a table to look at this one. We're going to have time and total number of cells. So we're going to start off after 1 minute. My 1 cell became 2, right? Okay. After 2 minutes, those 2 cells split in 2 and became 4. After 3 minutes, those 4 cells each split in 2 and became 8. So is this linear? Well, we go up by 1 and 1. We go up by 2 and 4. Is 2 over 1 equal to 4 over 1? No, so it's nonlinear. Try this one. John mows lawns. He charges his customers $15 per hour. A function relates to the number of hours John works and the amount he earns. Is the function linear or nonlinear? Let's make a table again for this one. So he has hours worked and money he earns. Let's call it E for earns. After 1 hour, he makes $15. 2 hours, he makes 30. 3 hours, he makes another 15, which would be 45. We could go on and on. Let's look at our changes. 1, 1, 15, and 15. So we have 15 over 1 is equal to 15 over 1. So it is a linear function. A couple special notes. If the function is proportional, it has to be linear, but not the other way around. It can be linear without being proportional. If it's both proportional and linear, the ratios will be exactly the same if we did output over input for our proportional test. This is your assignment.